the statement that's given is that if Alice does well in her classes, then Alice goes out with her friends. Now, in real life, people don't have to follow givens like this. They wouldn't. They can make up their own mind. They can change their mind, do whatever they want. However, this is a argument here where the word given means you accept that it's absolutely true. So assume that it's true, that if Alice does well in her classes, then Alice will go out with her friends. That's P, arrow, Q. It's also given, let's say that the instructor posts the grades, which is illegal these days, but if they did, and you could see that Alice did well in her classes, then that would be P. We want to create a truth table for Alice. So we want the columns P and Q, and then P arrow Q, where P stands for Alice does well. Q stands for Alice goes out. And the if-then statement is if Alice does well, then Alice goes out. Alright, so in a truth table with two statements like this, we want to analyze all combinations of true and false. So we just want that pattern of TT, TF, FT, and FF. And you have to know the form of a conditional. You have to know the form of a conditional truth table in order to analyze this argument. So do you remember when the conditional is false, I said there was only one way for a conditional to really be proven false? Well, the statement says that Alice doing well will lead to going out. If it ever happens that she does well and it doesn't lead to going out, then that would make this statement wrong, because they said it would lead to going out. And so when true leads to false, that is the only way to disprove this statement. It doesn't matter what happens if she doesn't do well, because the statement isn't about her not doing well. It's about what happens when she does well. Okay, so what we have here is T, F, T, T. That's always the form of a conditional. Alright, now, something that's new here is we can write the word premise above anything that's given. So like this column here, P arrow Q, was given, so it's called a premise of the argument. So what you can do is write premise above it. We have to assume it's absolutely true. If it's absolutely true, then we might as well only circle the trues in that column, because that's the only situation that we're going to consider. Not going to consider cases where it's wrong, because it's given. It's also given that Alice does well in the classes, so P is a premise. And you can circle the trues there as well. What we're trying to determine here is if we can logically conclude anything from this truth table. So there are 4 rows, 1, 2, 3, and 4. Which row is in complete agreement with the givens, where this is really the situation that Alice is in because she's got a true in all the premise columns? Which row am I talking about there? Yeah, I'm talking about row 1. Alice is in row 1 right now. Okay, where the statement about her doing well and that leading to going out, that was true. And also, we know that she did well because the instructor posted the grades. Can you make a conclusion about what will happen? What's the conclusion? Exactly. If P leads to Q and P happens, then Q must follow. It must be true. Alice goes out. Like I said, this is done in our minds. There's no way to know that this will actually apply to Alice in the real world. Okay? It's theoretical. What type of reasoning was used to make this conclusion? Abductive, inductive, or deductive? Yeah, it's deductive. That's right. It's deductive because it's guaranteed to be 100% true as long as the assumptions were true. And like I said, in the real world, we wouldn't know that they were absolutely true.